Hi guys, a very warm welcome, and in this video we are going to talk about well-architected framework. So after completing this module, you should be able to design the resilient architecture, design the multi-tier architecture, and design the performant architecture. So let us first understand, why do we need a well-architected framework? The well-architected framework means that how good your architecture is in terms of operational excellence, security, reliability, performance efficiency, and the cost optimization. So when you create a solution or deploy a solution on the AWS cloud, if your architecture that you have created follows these 5 pillars, then it will be considered as a well-architected framework. So well-architected framework helps cloud architects to build applications that follow these 5 pillars. Now, how we have to build the well-architected framework? First of all, we should build and deploy the solutions faster, and for that we should test the system regularly. We should use automation as much as possible, like for example using a CloudFormation, using Elastic Beanstalk, using the Lambda functions, and this way we can deploy our services and the resources very quickly. Lower or mitigate the risk. Understand risk in the architecture and address them before deploying to production. So there has to be a thorough discussion, thorough brainstorming before deploying the architecture on the AWS with respect to cost estimate, with respect to any gaps in the solution, and how the maintenance and the monitoring of that solution is going to be. What about the failovers? How the redundancy, and what is the backup plan for the disaster recovery? These are the risks that needs to be identified before deploying any kind of a solution to a production environment. Then we should be able to make the informed decisions. We should be able to determine the pros and the cons of the architecture decisions for performance and availability of your applications and business outcomes. Then we should also learn the AWS best practices and the recommendations. So we should follow some case studies that the AWS offers, refer thousands of customer architecture and trainings to take the best architecture design. So AWS gives us and recommends their best practices. We should follow that in our architecture deployment, even the architecture design also. And apart from that, similar to our requirement, we should also look into the case studies that how it was done by the organizations in the past. So the 5 pillars of a well-architected framework are, first of all, the security, second, the reliability, third, the performance efficiency, fourth, the cost optimization, and fifth, the operational excellence. So we need to ensure that our solution is properly secure from every aspect. Since cloud in the market, there is a perception that cloud platforms are not that secure. So we need to ensure that the security of our architecture has to be thorough. It should be a reliable. In case of any downtime or failure, it should be able to switch to another environment or another application. Performance efficiency. It should be performance efficient. Whatever resources that you are going to create, you need to ensure that you have designed or selected the proper capacity of those resources. And apart from that, we need to do the cost optimization wherever it is possible. Last, after the project or the solution is deployed on the AWS cloud, we need to ensure that there is a proper maintenance and the troubleshooting happens on the solution. If there are any errors or logs that are generated for errors, they should be identified very quickly and they should be resolved as soon as possible. So how we can design the resilient architecture? So first of all, what is resilience? Resilience is also called as recoverability. How soon we can actually recover our solution if there is any failover or there is any downtime. Resiliency is also the capacity to adapt to changing conditions as well. Quickly maintain and regain the functionality. A software is reliable if it is able to quickly recover from the failure as well. So how resilient architecture overcomes the failure? AWS provides multi-geographical regions to host your application. And here you can see all the blue dots are the current active regions of an AWS. All the red dots are the coming soon regions. And each region has multiple availability zones. And each availability zone has multiple data centers. So a resilient architecture deals with failure through high availability and the fault tolerance. That means, let's say if you plan to create an architecture or if you plan to create a solution on the cloud, you can select a region. Let's say I select a Mumbai region, and in the Mumbai region I have 3 availability zones. So I'll spread my solution in such a way that it should be available in all the 3 availability zones, and that makes my solution a highly available solution. In case if I need to plan a backup also, a disaster recovery also, so I may go with any other AWS region for creating a backup of the same solution. And whenever that kind of a failure happens, it would be quickly, or the traffic will be quickly shifted to that backup solution. And that is what the resilient architecture overcome failure means, based on the proper design and the implementation. So here you can see this is an example of a design resilient architecture. It's a 2-tier architecture only, and you would see that the user tries to access a web page, and from the Route 53, which is a global service, the request is sent to the load balancer, and the load balancer forwards that request or distributes the traffic equally to the web instances in the different availability zones. And these web instances are connected in the backend with the master database instance, and this master database instance synchronizes the data to the standby database instance in a different availability zone. So this is basically an example of a 2-tier resilient architecture. And how it is resilient? For example, let's say if a web instance fails, we have another web instance that is working. If a database instance fails in the availability zone, then we have a secondary database also. In case if an entire availability zone fails, still we have another availability zone. Alright.